Right. In this lecture, we are going to study to solve a problem. We're going to solve a problem related to fixed bias JFET configuration. This is the circuit where RG is given to be 1 mega ohm, RD is 2 kilo ohm, VDD is 16 volts, and VGG 2 volts. And these are two datasheet parameters. IDSS is given to be 10 milliamperes, and VP is -8. So first we write input loop equation to find VGS. We write input loop equation as, we write this 2 as negative because it's a voltage drop. We are entering from the positive side, minus IGRG, which is RG is 1 mag, plus the voltage drop minus the voltage drop, because we are writing voltage drops as negative. So this term becomes 0 because IG is 0. There is no gate current, we know. So VGS comes out to be -2 volts for this circuit. Right. Before we write output loop equation and find VDS, the voltage between drain and source, this voltage, we have to apply the Shockley's formula to find out the value of ID. The IDSS and VP are parameters taken from the datasheet. IDSS is the maximum current ID obtained when VGS is equal to 0 volts, and VP -8 is the voltage, the value of VGS for which the negative is the most negative voltage for which ID becomes 0. So IDSS, put values of these datasheet parameters here. VGS is -2, I just calculated, over -8. So ID comes out to be 5.6 milliamperes. The next is to find the other quantity making the bias point, VDS. For VDS, we need to write down the output loop equation. In the output loop equation, we have a VDD, voltage rise, negative positive, minus the voltage drop across RD, which is IDRD, minus the voltage drop here, VDS. Voltage drops, this is voltage rise. VDD is 16, minus ID, we have just calculated, is 5.6 milli, times RD given to be 2K, minus VDS is equal to 0. So this gives us VDS equal to 4.75 volts. Once we are given these quantities, you can find out the bias point. Bias point voltage drain to source is 4.74, ID is 5.6 milliamperes. In addition to these quantities, we are asked to calculate a few more quantities. That is, we need to compute the voltage VD. It's different from VDS because VDS is the voltage between drain and source, where VD is the voltage between the drain terminal and ground. Since in this case sources are connected to ground, only in this case VD is the same as VDS. But if we have a source resistor here, then of course they are not equal. So luckily they are equal here, 4.75 volts. VG is the voltage drop across every resistor if it is there, plus the VGS. Since source is directly connected to ground, there is no RS, VGS is the same as VG. Right, but if you have a source resistor, then of course these voltages are different. It's -2 volts. The last quantity that we are asked to compute is VS. VS is the voltage of source with respect to ground. This voltage from source to ground. Since source is directly connected to ground, VS has to be at 0 volts. In the next lectures, we will study more biasing techniques related to JFETs. Thank you.